Okay, physicists, what we're doing today is we're working on circuits. And so we have a battery, we have a light bulb, and we have a wire. And if you were in person, what we would be doing is having you experiment with how to light the light bulb up. So the most common thing that I see often is someone will take the battery, they'll connect the one end of the battery, and then they'll try and connect the other end of the light bulb here. And if you notice when I do that, nothing happens to the light bulb. If I touch the other end of the light bulb here, that doesn't work either. If I touch the other end of the battery and do that, it doesn't work. So then we start thinking about through the fact that the battery has two ends to it, which is a positive end and a negative end. So it's labeled here, the one with the dimple is the positive end, the one without the dimple or the flat side is your negative end. Well, the light bulb also has two ends to it. One end is the casing. So the one part of the casing comes up and touches into the filament, comes out the other side of the filament and comes down through into the dimple of the light bulb. And then this black stuff is an insulator around it. So there's an in and out for the light bulb too. Now, when we think through this, electric current or the flow of the electrons, it has to have a continuous loop in order for the light bulb to light up. So one of the ways that I might do that with one wire, one bulb, and one battery is to connect one side of the battery with the wire, to connect the casing of the light bulb to the one side of the battery, and then to connect the other side, the dimple, with the other side of the wire. So notice that the light bulb lights up whenever I do that. So I have a complete loop where it comes out of the battery into the dimple of the light bulb, out through the filament and out the casing back into the other side of the battery. So whenever we look at the different ways we could draw this, then that's one example where I might have my battery is here, and so there's a battery. I might have the light bulb here with the dimple, and then I have the wire that goes from the dimple around to the other side. So if you look in the green part, what would happen is the electrons then, they would come out the negative side of the battery, travel through the wire into the dimple, into the filament, and out the casing and back into the other side of the battery, and there would be my complete loop. So I'd have that. So remember, if there are two, like an in and out for each electric object, then we could take and literally do the same thing if I had it this way, where the light bulb casing was on the one end of the battery. What if I literally just flip my battery over and touch the light bulb casing to the other side? Does that work? So give me a second to get my two hands to do this. So if I put this on the other side like that, pinch that, and then connect it, notice that it also works. So that would be another way that we could connect those. I'm going to change my battery here. So I'm going to put my battery this way, this way, this way. And then for the light bulb, we have the light bulb casing on the edge of this side of the battery and the dimple. And then we have the wire that came out one side of the battery and into the dimple. Okay, so I'm going to keep in mind, I'm not running it back into the casing, otherwise I'll be running straight through the casing and into the battery. And so what the electrons are doing in this case is, again, they are flowing out the negative side into the casing, through the filament, and then down through the middle into the dimple and around the wire and back into the other side of the battery. Okay, now, if the battery has an in and an out, like we said earlier, so does the light bulb have an in and an out. So I could literally take this one where I had the casing on the battery, the dimple. What if I turned it so that the dimple is on the dimple? So I'm changing my in and my out again. Again, here, give me a second to see if I can get my fingers to do this. So I'm pinching the dimple on the dimple, and then when I touch the casing, notice how it lights up. So that would be a third way that we could do that. So I'm going to take and draw my battery, battery, battery. I have my dimple on the dimple. And then I would have my wire would come out the negative end and touch the casing of the light bulb. So again, what's happening is the electrons are flowing out the negative end, around through the wire, into the casing, up into the filament, and down through into the dimple, back into the into the positive side of the battery. So it creates that one complete loop that we have there. Now, the last one then, you guys will be taking and flipping our battery the other way and doing the exact same thing, only putting our dimple on it. So we would take and put the, if I redraw this here, and then I put my dimple of the light bulb down here, casing, bulb itself, run the wire out of the positive and into the casing side of that. So then my electrons will come out the battery through the dimple, up into the filament, down into the casing, and out the casing into the wire and out the positive side, and there would be a complete loop for that. So remember, the idea, there has to be a complete loop for the electrons to flow, and the electrons have to flow through the object that you want to power. So for instance, down here, it's asking for what are some ways that we could short circuit it. So think through, if I take my battery and I put my casing on the battery, then I pinch my wire to the other side, but now I touch the casing with that. Notice how nothing happens. Nothing is happening with that. So the reason is because if I have my battery, there's my battery, and here's my casing, dimple, casing, bulb, and my wire is touching the casing and coming out to the other side. So what is literally happening with the electrons is that the electrons, they'll come out the negative side, go around through the wire into the casing, and then they'll come out the other side of the casing back into the battery. So they don't ever go through the light bulb, they only go through that casing, which means the light bulb isn't going to light up. So if you think through what another way to do that would be that you would have your battery, and oftentimes the students will try and take and put their dimple against the dimple like we did, but instead of running the wire from the negative side up into the casing, they run the wire up in and just touch the dimple of the battery. Well, when you do that, the same thing happens as what happens over here. Is the electrons are going to come out, they'll come around, they'll go into the dimple, they'll come out the dimple back into the battery, and they never actually go up into the light bulb in order to power or light the bulb. So those are two ways that we could short circuit it. You can obviously think through the same way we did up here. You could flip your battery and do the same thing down there. And the last one, you don't even need to have a light bulb to short circuit it. If you literally take your battery and you connect your wire from one end to the other and pinch those two wires on there, that's going to short circuit it because the electrons will flow out one side into the other, and within a minute or so, your wire is going to get really hot, and it's going to be hard for you to pinch and hold that value, hold those two wires onto that. Now, we technically could say there is a third element in this lab. We have the battery and the bulb that we flip-flop both sides. We could say that we could flip-flop the wire also. There is nothing really that shows us that says like one end of the wire versus the other end of the wire. So we'll just kind of take that out because it would really give us 4 more options where we're flip-flopping each of these with those different ones. So in essence, that's the circuit lab. Key idea, the electrons have to flow into and through the object that you want to power, and then you can't skip parts of it because any place where there's a continuous flow of electrons without any resistance, that's going to short circuit your battery.